So hello students, I guess you are fit and fine at your place. So let's start today's class. Okay students? So students, I have something for you. So student, firstly you have to identify the geometrical shape for this given figure. So please write it down your answer in the comment box and later on I will check it your answer from there. Okay? Yes, very good. So this is a right angle triangle. Very good students. What about this? One stick is there, right? So what kind of geometrical shape if we talk about? Is it a line segment, ray? Yes, very good. So it is a, firstly you told me it is a right angle triangle. And second, we have a line segment. Okay students, now what you have to tell me, let's see. So students, we are going to do an activity. Okay, so see, I have a right angle triangle and I place the stick. So you can see there we have a naming for this. This is an C and this is a B point and this is a A point. Okay, so we are going to rotate this one. So look it carefully when I am rotating. So when I am rotating students, do you find any circular pattern? Yes, when I am rotating it, do you find any pattern? Let me show you what kind of pattern. So see, let us consider this is in height, and if we rotate in this clockwise or if we rotate anti-clockwise, do we get the same shape? Yes students, see, we get this kind of shape which is like a cone, right? So we get a shape which is act as a cone. So let me write it down. This is a cone, right? But students, do you notice whenever I rotate it in the anti-clockwise or clockwise direction, I get the same cone, right? So what kind of cone it is? Do you find it any right angle triangle? Yes, right angle, 90 degree. Yes. See, we have this ice cream also. You have eaten this kind of shape of a cone, right? So this is a cone, you can see it. I'm going to mark it. So let me draw a line for it so that you will easily come to know that. So this is a 90 degree and this is other side. So basically students, this is a cone which is following a criteria of a 90 degree, right? And which cone is it? See, we are going to tell about today's topic of discussion, that is right circular cone. Okay, so whenever you rotate it, so this is our topic of discussion. We are going to talk about its surface area of right circular cone, its concept and application we are going to discuss. Okay, so students, you can see it whenever we add something into the cone, so we have to find out how much amount is there or how much that we needed to cover that outer part, right? So that way we are find it out the surface areas for this right circular cone. So here you can see this is a right circular cone because it forms a 90 degree and it's in a circular form. As you can see, this is a 90 degree right angle triangle, and if I rotate it in clockwise or anti-clockwise, again I get same 90 degree axis, right? It is a perpendicular to the base, which is we have a circular part. You can see this is a circular part and we have a radius which is r. Okay, so this right circular cone is a circular cone whose axis is perpendicular to its base. So whenever we calculate it or whenever we find it out which is one of the following is the right circular cone, so you have to remember these points as that is axis is always perpendicular to its base. So this is act as a axis and this is act as a height, right? So when you calculate or when you rotate, so this is a circular cone, you will get it, and its base is going to be perpendicular. Okay, so that way you can see it. So this is other form when you make any cone from the paper. Okay, now students, let's talk about the curved surface area of a cone. So first, the curved surface area of a cone means the outer part. If I want to calculate, this cone is there, only this outside part, okay, not this circular part. We are eliminating the circular part. So see students, how you get this curved surface area of a cone. Whenever we draw any cone or make any cone, so you require a paper which is in circular form, right? And you will cut it. When you cut this paper, you will get into small triangles. Okay, so we can give the names to them. We can give as you can see here, and okay, so we will give the name to the radius for this circular, and then we will calculate what is the area. Okay, so see, if we given the distance as a t and small triangles you can see, all right, so we can give the names to this triangle. So whenever we calculate the curved surface area, we have to add all the small triangles that you see in this part. So we know that the area of a triangle, that is half into base into height. This is area of a triangle, right? Area for triangle. So what we need to calculate? So we will calculate by adding all. So students, we know that there is a slant height which is in front of you. This is a slant height. Okay, so slant height means students, this is a particularly a height, this is a radius, but students, in between we have a slant height which is coming out as, okay, that is L. So you have to take the slant height as L, and for B we have to calculate for all. So we know that this circumference of a base, that is a circle, that we know that is 2 pi r. So we will calculate with the help of this. So that's why we get the circular part for this is a 2 pi r. So you will just multiply half. So let me tell you how it is coming out. So that is half into, that is 2 pi r, that is in circular part, and for the slant height. Okay, so these you will cancel out all the terms, you get pi r L. So this is the curved surface area for cone. Okay students, so please remember, for the right circular cone we have a pi r. Now students, if we talk about the total surface area, so we know that for the total surface area we have to add curved surface area as well as the area of a base which is a circular, right? So we have pi rl is the curved surface area, and pi rl is the curved surface area, and pi r square, that is the area of a circle which is in the base. So that's why you get, and you will calculate and make it simplified form, so that way you will get this as a curved total surface area for the right circular cone. Now students, you have to enlist some examples of right circular cone from your surrounding. So please search out some examples. Where do you see the right circular cone? Yes, very good students. So you can write it down your answer in the comment box. From there I will going to check out your answer. Okay, so so very good. So see, I have pasted some examples of a right circular cone. Let's see, you can see you in the Christmas tree, right? So in the Christmas tree we have a right circular cone. Let me make it. So this type of shape is there in the birthday cap also. And if we talk about for the cone, ice cream cone and plain top, so these are the few examples of a right circular cone. Now students, you have to do this task, filling the blanks. A dash is a circular cone whose axis is perpendicular to its base. So what is that circular cone? What we call that circular cone? Yes, very good students, that is right circular cone. This kind of cone is always perpendicular to its base. Okay, yes students. Now students, please read this question and tell me how we are going to proceed for this question. Yes, you have to find the curved surface area of a right circular cone whose length height is given to you, which is 10 centimeter, right, and its base is given to you of a radius is 7 centimeter. So we know that curved surface area of a right circular cone, what is that students? Please write it down in answer in comment box. For CSA, what is that? Yes, it is pi r l. Okay, now what you have to do? So firstly, I pasted two images students. So which one of them you consider is for calculating the right circular cone curved surface area? Which image is showing the curved surface area? Let me give you the answer. You can go with one, and this is for the two. Okay, so which one of these you will choose for the right circular cone? Yes, very good. So basically we have the answers from the students, that is first one is going to choose for the right circular cone for the curved surface area, because we know that we can see here on the this part of it, it is blank, right? So that way we can see that we are going to calculate for this one. So students, firstly we have something in given points, that is slant height is given to you, which is L, right? This is given to you, that is 10 centimeter, and radius is given to you, which is 7 centimeter. So students, we have the known terms, so you just substitute all the terms and calculate the answer for this. So let's do it together. So we have to use for the pi value, you can use 22/7. Okay, so that going to be easy for you. So we have radius 7 and the slant height 10. So calculate is and tell me the answer. Students, make sure the unit should be proper, that is centimeter square, because we are calculating here area, so we require only square units. Okay, so tell me what is the answer. Yes, if you cancel out all the terms, we get 220 centimeter square. So this is our curved surface area of a right circular cone. Okay, so please note it down and match your answer with my answer. Do you get the same answer? And those who get it, write it down your answer in the comment box. Okay students, now come forward. Now students, find the total surface area of right circular cone whose length height is 10 centimeter and base is 7 centimeter. Now students, tell me which factor of these two, 1 and 2, you will going, this is for 1 and this is for 2, which one you are going to choose? Yes, so yes, the second one, because it is totally you have to cover it, right, for the circular part also. Very good. So we have to consider this second figure. So students, this is the same, we already have find it out the curved surface area, we have to find it out total surface area. So what is the value for the total surface area? Firstly tell me the formula, let me write it down. You also write it down the answer in the comment box for the total surface area for this. Yes, that is curved surface area, that is pi RL, and we require one more, that is pi r square, right? So we will take some terms common and simplify it, that is pi r l plus r. Okay, so this is the formula for the total surface area. So we have slant height, we have height, radius, so we will calculate it. Okay, so total surface area, we know that pi r. So we have done it, so let me take it out the answer. So we have get the total surface area, this formula, right? So we will substitute all the terms. So that is 22 by 7 and radius is 7 and the slant is 10 and you have to add the 7. Okay, so now cancel out all the terms and add this also, 22 by 7 into 1 into 17. So please calculate the answer and tell me what is the answer. Okay, so let me write it down. Those who have done it, please cross check it. Do we get the same answer or not? Yes, students, do you get this answer? You can check out your answer. Okay, so that way we can calculate our total surface area and the curved surface area of any figure. Okay, that is for the right circular cone. Students, it's your task to do it. So please read the statement, then give me the answer. The total surface area of a cone is calculated with the formula, that is pi r l. Yes, you will calculate it. Is it a correct statement or not? Yes, very good, students. This is a false statement because we know that this is not a total surface area, this is a curved surface area. So instead of the total, we required here curved surface area. Okay, now students, identify the name of this image and write it down, answer in the comment box. Yes, very good. So I guess you have completed your task to giving me the answer. So this is corn cob, right? Have you eaten? You ate it in the summer time mostly, right? Or winter time, so we eat it. So students, let's come forward. So according to that, we have a question, students. So what we have, a corn cob is there, which is in the shape, you can see the figure which I pasted in the right hand side, somewhat like a cone, right? So you can see this is like a cone. Okay, so it is like a cone. So students, we have a radius. So let me write it down what are given to us. So we have a radius which is 2.1 centimeter, right? And the length or the height is given to us. So that means height is given to us which is 20 centimeter. Okay. Now students, if each 1 centimeter square of the surface of a cob carries an average of 4 grains, okay, how many grains would you find it out for the entire cob? You have to take pi value as a 22 by 7. So students, what we have to do it? How you will proceed for this question? What we have to calculate? Is it a total surface area or the curved surface area? Yes, we have to calculate the curved surface area, right? Yes, okay. So tell me how you will do it. So do we have all the requirements? As we know that for the curved surface area, we require pi r l. So do we have pi? Yes. Do we have radius? Yes. Do we have L slant height? No. Students, here we have a height. We don't have slant height. So how you will calculate it? So students, we will calculate with the help of this formula. That is, we know that Pythagoras theorem. So you will see this right circular triangle, right. So this is a 90-degree, right? So let me make a one triangle for you. So do you know this is a Pythagoras theorem, right? So here is the slant height, this is a height, and this is the radius. Now use this Pythagoras theorem and calculate for the slant height. So we know that L square is equal to R square plus H square. So we will use this one to calculating. So you will just substitute all the values which we have, that is 2.1 centimeter square, and for the height we have 20. So calculate it, and if we remove the square from here, so the square root will come on the other side. So calculate the value and tell me what do you get for the slant height. Write it down on your answer in the comment box for the slant height. Do you get answer? Let me write it down what I get the answer. That is 20.11. So this is our slant height for this. This is our slant height for this question. Okay. So now we will calculate. Now we have all the values. So now we are going to substitute. Okay. So we know that curved surface area, that is pi RL. So substituted students, that is 22/7, and radius we have 2.1, and we get 20. Tell me the answer. What you get at the last for the curved surface area for this? Yes. Yes, okay. So whenever you cancel out, you get 0.3 and multiply all the terms. So you will get nearly, yes, okay. So you will get nearly 132.76 centimeter square. So this is our curved surface area. We have find it out. Now students, let's see what we have to do. Now you have to calculate how can we find it out number of grains in that particular cone. So for the cone we require that number of grains, how many grains are there for that particular cone. So how you will calculate, because we have given that, for that we will use the number of grains of a cone on for the 1 centimeter. We can say the 4 are there, right? So what we will do, we just multiply our curved surface area that we get it with the 4. So we get the number of grains which is on the curve. So we will write it down the answer, which we get 132.76. So tell me the answer. When you multiply, what you get it? Yes, you will get nearly 5. 1 minute. 5, 3, 1. So these are the grains in a particular this cone. Okay. So 531 grains. Now students, do it this question. You have given a statement along with 4 options. So you have to solve this. Yes, we have a height, we have a radius, so but we have to calculate the slant height. So how you will calculate? Yes, we will use the Pythagoras theorem. Very good. So we know that L square, H square plus R square, we get this much. So we have to calculate. So again we have to H square plus R square. So you just substitute all the values and tell me the answer. What do you get? Yes, 20 centimeter. Very good. So that means the B is the correct answer. Okay students, so let's recap what we have discussed today. So we have discussed about a right circular cone, a circular cone whose axis is perpendicular, right? So we have curved surface area, that is pi r l, and the total surface area pi r plus bracket l plus r. So this is our total surface area. Now these are the few examples we discussed about real life applications of right circular cone. So these are the 3 questions you have to do at your home. Read the statement particularly and then do it. Okay. And this is the last activity. The materials are required in front of you is written, and the 3 steps are there, and you have to write it down your observations when you get it, and you have to verify the total surface area as well as the curved surface area for this particular. Okay. So thank you students. We will